So we are done with our solution, and in this section we will try to see how to animate our solution and how to see transient heat transfer problem. In order to do that, we need to change some parameters here. So we will not touch anything in the solution setup and the solution section except in the monitor section. So go to monitor. In the residue section, go to edit and uncheck this plot option. So in the print option, that means these parameters you can see here in the text module. Select OK and then go to solution and initialize. So your solution will be initialized, and then go to this option, calculation activities. In our previous problem we never talked about this option, but today we will discuss a little bit about this solution activities. Here in the bottom you can see here solution animation. So go to create and animation sequence, select this and the name of your animation, let's say temperature, and you can see the solution after each iteration or each time step. So as we are doing transient heat transfer problem, we will try to see after each time step. So select time step and go to define. Here you can see how to define your solution. So you can see the contours, path line, particle track or plot or vector field. So we are interested in contour, so go to contour and we want to see the static temperature. So select temperature, static temperature and display. So right now it's the initial condition. As you can see, we initialized, so right now it looks like this. So don't worry about that. Then close, select OK and OK. Now go to run calculation, and here our time step size is 0.1 second and the number of time steps is 350. That means the actual physical time will be 35 seconds and the maximum iteration for each time step is 1. So we will put these things and we will start calculation. So select calculate and it will start calculating and it will update your solution. So as you can see here, your hot fluid and your cold water is coming from each tube, and eventually it will mix. So right now it starts mixing. As we are doing K-epsilon model, so you cannot see the vortices because it's so you can see the mixing process and the temperature contour. So the hot side is getting cold and your cold fluid is getting hot, and eventually it will mix up. Okay, so our solution has been done. So we did, the actual flow time is 35 seconds with a time step of 350, and our time step size was 0.1 second. So right now we want to see this movie. So go to graphics and animation. Here you have the animation option. Go to solution animation playback. Go here, setup, and go here, write and record format, and select MPEG, and then write. So it will write your solution and it will make a movie with a MPEG format, and we can save it and we can show in our presentation. So as you can see very clearly, the solution process is going on. Actually right now it's rendering the solution and eventually it will save the solution. So right now it's the rendering going on. You can see these time steps. So it's rendering, and when it finishes after 350 iteration, it will update the status. Now you can see it's updating each and every frame, and eventually it will save as an MPEG file format. So now it's done. So we will try to see the movie. So in order to do that, you have to go to the file where you saved it. So as you can see, mixing channel I saved here, and it has the backup file here. So when you saved any ANSYS workbench file, it creates two files. One is the exe file and another is the extension file. So we have to go to extension file. So go to extension file and then go to dp0 FFF fluent. Here you can see each and every frame has been saved, and somewhere you can see the file format for the movie. So double click here, you will see the movie. So you can see the movie, it's been saved, and you can see the time steps. You can play back this movie again and again and you can see your solution. So this is how we animate our solution, and we will see how this K-epsilon model differs with LES model.